Alright, so you're given the AF bisects angle BAC. So here's AF. If it's bisecting this angle, it means it cuts it in half, right? So then 1 and 2 have to be congruent. And then the parallels, this is the one that I think is a little bit harder to see. DE is parallel to AB. And this is where I like to highlight things to kind of make it a little bit easier to look at. So if I highlight the parallels, they gave them to us for a reason. We have to find a transversal that's useful. So if we look at this transversal, we don't really have any alternate interiors because that would be like this angle and that angle. And we don't have, there's no exterior angles at all. Corresponding, we don't have those. We have same side interior, like here and here, adding up to 180, but those are no fun. So there isn't a lot that looks fun there. So before looking at it more, go to the other transversal and see if maybe that transversal is more helpful. So now looking at this transversal, and this is where, maybe turn your paper, and you'll see that it's not a Z, but you have a backwards Z right here. And anytime you have a Z, that gives you alternate interiors.
Yeah.
So we know that angle 1 has to match angle 3 for that little Z. And then I like to write it down. Well, if 1 matches 2 and 1 matches 3, that tells me 2 has to match 3. And then the question asks you to prove that it's isosceles. Isosceles means 2 congruent sides. But this is a triangle. And if we have that the angles are the same, that can lead you to the sides. So it looks like if we have the bisector, so that gives you angle 1 congruent to angle 2. Our other given gave us that 1 is congruent to angle 3 because they're alternate interior angles. Transitive links those because it's a congruent symbol, not equal sign like substitution. And then the last 2 steps, if 2 angles of a triangle are congruent, then the sides opposite them are congruent. You have to say, oops, bad color, of a triangle. If you skip that, it's not right. And then the sides lead you to isosceles. So the last 2 steps for isosceles are pretty much always the same. Sides give you isosceles. Sometimes you have to do angles give you sides, sides gives you isosceles.